Good morning. Today we are going to discuss about the clastic sedimentary rock deposits. In our last session, we have studied about the residual sedimentary rock deposit. In residual sedimentary rock deposit, we have seen that how the in situ formation of the sediments and the in situ accumulation results into the residual concentration or residual sedimentary rock deposits. So the clastic sedimentary rock deposits are quite different from the residual concentration or residual sedimentary deposits. But the first step of the residual and the clastic sedimentary deposits is same, that is weathering. So the both type of rock needs weathering, and without that you cannot go further. In residual, you get the residual concentration as the further process, whereas in clastic, you will get the erosive or the transportation after the weathering. So let us discuss about the clastic sedimentary rock deposits. So clastic sedimentary rocks or deposits are made up of sediments. They are also called as clasts, hence the name clastic sedimentary deposits. So these clasts are of the pre-existing rock. Okay, so you must understand that there has to be a pre-existing rock from which the sediments will develop. These sediments are the loosened by weathering. Okay, so weathering is the chief process behind the formation of these sediments or clasts. Without weathering, you will not get any kind of sediment of the pre-existing rock. So that pre-existing rock should get exposed to the weathering agencies like of atmospheric, okay, where you can get the mechanical disintegration or chemical decomposition. So the cumulative effect of these weathering processes results into the formation of sediments. Then those sediments are transported to some basin or depression, means where the velocity of the agencies are checked. So what are the agencies? River, glacier, wind. They carries those sediments from the site of the formation to the depositional basins. And if these sediments are buried and become compacted and cemented, ultimately you will get the sedimentary rock. So let us see how the weathering affects the clastic sedimentary rock. So the formation of clast or sediments. The first step for the formation of the clastic sedimentary rock is the formation of the clast or the sediments. Weathering is responsible for the formation of the clast from the pre-existing rocks. So weathering is the chief process which actually is responsible for the formation of clast or the sediments. They are formed on the basis of mechanical disintegration or chemical decomposition. So mechanical disintegration and chemical decomposition depends on the environment or the climate of that area. So for example, if you have a very hot climate, like in deserts, so you will get mechanical disintegrations dominance because the water quantity in the air is very less and hence the chemical decomposition is suppressed. But if you go to the region like tropical region where the humidity is high enough to ignite chemical reactions, in that case you may get mechanical disintegration as well as chemical decomposition. So ultimately it depends upon the climate, what kind of climate is there, and accordingly the rock suffers from different type of weatherings. So say for example, if you have a tropical climate, then you will get the chemical decomposition and mechanical disintegration together. So ultimately that rock will convert into loose fragments because of this weathering, and that are also called as immature sediments. Okay, those sediments will be then transported with the help of agencies. The agency could be wind, water, glacier. So these agencies will carry forward those sediments. But during this transportation, they also experiences erosive processes. So what are the erosive processes are? The erosive processes are like abrasion, atteration, okay, where the sediments collide with each other. The sediments collide with the bed of the of the surface of the earth from where the agency is flowing, and in that case they will experience the erosive activities. So during these erosive activities, they will again, they will get designed accordingly. If the sediment is highly transported, their grain size will become smaller and smaller. If the transportation is less, then the grain size will be coarser. At the same time, less transportation indicates angular fragments, higher transportation indicates a rounded fragment, and then it again affects the sorting of the sediments. Higher transported sediments show good sorting, whereas less transported sediments shows poor sorting. So accordingly, the clast and the sediments are formed and designed with the help of weathering and erosion. And then further, that I have already discussed it in 2 or 3 classes, that then they will be subjected to the diagenesis processes where deposition, compaction, cementation, lithification, and ultimately the cumulative process diagenesis will happen, and ultimately you will get the sedimentary rocks. So let us see a few well-known examples of sedimentary rock. The rudaceous sedimentary rocks, or rudaceous clastic sedimentary rock. Rudaceous rocks are those rocks whose grain size are quite coarser. Okay, just like gravels or boulders, cobble pebbles. The grain size is very big. Okay, much bigger than you have ever imagined in the rocks. So you can see here the grain size is larger than 256 mm if it is boulder. For cobble it is different, and for pebble it is different. When such kind of larger sediments are agglomerated in the rock or in the depository basin, then it will form the rudaceous type of sedimentary rock or rudaceous type of clastic sedimentary rock. The well-known example is conglomerate. This rock is called as conglomerate because the grains here are quite rounded. If the grains would have been angular, then this rock would have been named as brachia because the angularity decides the name. If it is rounded, it is conglomerate, and if it is angular, then it is named as brachia. But you will see that the grains are quite coarser in size, quite big in size. It indicates the less transportation, okay, because it has suffered less transportation, because of which the grain size uh, does not goes to the finer level, and they remains very coarser, and because of which they are classified as ratios. So it indicates the less transportation. And of course, in such kind of rock, you will get low sorting or bad sorting, okay, because there are coarser grains, but at the same time you will get the finer grains of those minerals which are less resistant to the weathering, and because of which you will get a poor sorting. So poor sorting, coarser grains, okay, angularity, these all things explains about the less transportation. And rudaceous rock are the well-known example. The another well-known classification of classic sedimentary rock is arenaceous. Arenaceous rocks are those rocks where the grain size belongs to the sand size. So the sand size, you have seen the sand in the riverbed, as well as when you have, if you have ever observed or experienced the construction of the home or the house, you would have seen sand very closely. So sand size is quite different from the gravels, pebbles, and cobbles. You can see here the measurement of the sand. Okay, how you can see the sand is coarser, medium, and fine, and ultimately they have different kind of grain sizes. So the rock which is formed because of the agglomeration or of the compaction of the sand is well known as sandstone. So they are, if the sand is very coarse, they can be classified under medium transported sedimentary rock. Because of the medium transportation, the grain size has become, lesser than the rudaceous rocks, but higher than the argillaceous rocks. They are mostly medium to good sorted, okay, because due to higher transportation, there is an, you know, the sediments became of equal size. Okay, the sorting becomes good. Okay, and because of which the sedimentary rocks are quite uniform or homogeneous in appearance. Similarly, if you will compare the mineralogy of the rhodaceous rock and the arenaceous rock, you will get much uniform or homogeneous mineralogy than arenaceous rock when compared to the rhodaceous rock. This again is attributed to the higher transportation. The well-known example is sandstone. The another and well-known example is the argillaceous rock. Here the example is shell. Okay, siltstone is also there, but you know the well-known example is shell. Here the grain size is very fine. Okay, you can see the silt size is 2 micrometer to 63 micrometer, and in clay it is less than 2 micrometer. Means it is very fine. Okay, this fine sediment, this fineness of the sediment is attributed to the highest transportation the sediments have suffered. Say, for example, on the beaches or in on the continental shelves, or where the river meets the ocean and the sediments are deposited at the bottom of the ocean, there only the much or the finest sediment can reach up to that level, because most of these sediments are in the soluble or suspended form. So when the river or the agency has its maximum attainment of the distance, or we can say the at the oldest age of the river, or at the maximum distance the wind can cover, these sediments can be in the suspended load. But when the wind or the river, stops entirely, or the velocity of these agencies are checked completely, in that case, those sediments which are suspended and dissolved, they get precipitated. And at that location, you can get such kind of fine sediments. So these are formed at the extreme ends of the transporting agencies, and they are classified as argillaceous rock. Here the transportation is highest, and hence the sorting is excellent, as well as the grain size is very fine. The roundness and the other things are, no doubt, they are very good and very mm, perfect. So this is about the argillaceous rock. So let us revise what we have studied in the clastic sedimentary rock. Okay, in the clastic sedimentary rock, we have seen that how they are different from the residual rocks. Both the formation of both these rocks starts from the weathering, but residual rock further moves in another direction to the residual concentration, whereas clastic rock moves for the erosion, transportation, and so on, so on. So then we have seen the definition of the clastic sedimentary rock, that how the sediments are formed and how they are transported and deposited. Then we have seen the formation of clast and sediment, where weathering and erosion are holded to be the prime responsible for such kind of formation, because without which you will never get the sedimentary sediments of the pre-existing rocks. Then we have seen the radiaceous sedimentary rock, where you can see that the grains are quite coarser in size. Okay, we have seen the grain sizes of them. One example is conglomerate. Then we have seen the arenaceous rock. Okay, there are other subclassification where the sandstone is an example, and the respective grain sizes are given here. Then we have seen the argillaceous rock. The well-known example is shell, and it is the finest grained rock you may ever get. And you can see the grain size, which is much lower. It is 2 micrometer to 63 micrometer for silt, and for clay it is smaller than 2 micrometer, which is very fine. You are not even able to see the grain size by the naked eye. You need the assistance of microscope. So thank you very much for your patience listening. And today we are going to have our unit test one on our unit one by 12:30. So I am going to share the Google link on your WhatsApp group, and you'll get in a half an hour to solve that unit test. And the questions will be from the unit one. So, and I have already shared my notes and study materials and e-contents. I have also shared my YouTube links through which you can revise your lectures. Okay, and ultimately you have to give your, or you have to attempt your unit test, because ultimately they are going to decide your internal assessment marks. So hopefully you have got what I taught today, and I'm also sharing the remedial coaching link through which you can put your doubts, and I will resolve them as soon as possible. Thank you very much for your attention. Thank you very much.